SARP is a hands-on program for students to get experience in the field with instruments working on NASA science. It's focused on Earth system science, airborne measurements, atmospheric science, oceanography, land surface science, using a combination of in situ measurements that make the measurements of the air that the planes fly through, as well as remote sensing instruments that can look down at the ground or look at the atmosphere or look at the ocean surface. The students get a chance to be involved with making measurements. They go in the field and make surface measurements that complement those from the aircraft, and then they work with the data that they have, doing scientific data analysis. Since this is the 10th year of SARP, they not only get to work with the data that they get, but the data that their predecessors have gotten, and not just the data on the plane, but measurements on the ground that they make as well. In many cases, it's the same sensors flying the same time of year in the same places, so they can see how this year is different from other years.
So all you got to do is open the inlet, open the outlet.
All the way?
All the way and then close it.
Then take note of what pressure your gauge is at, because we want to see if it changes.
We've been able to have a lot of hands-on experience, especially with a lot of the instruments. We only really get to see things like pictures and maps and graphs and other data at school, but here we get to look at actual instruments, see how they work, talk to technicians, and see how data is really collected in the field.
We're taking measurements real time of methane, CO, water vapor, and a bunch of different real-time measurements. It's really cool to see how these are fluctuating when we're flying over different environments.
It's been a lot of fun. It's been fun to learn about all the different sensors, how everything works. What we're looking at on the screen here is how formaldehyde is changing with the different conditions below us, as well as altitude. So depending on whether we're in the mixed layer or above it, there's different changes in the formaldehyde concentrations that the plane is flying through.
You get to dream about, doing all this science in the field, and you literally are doing it right now. Like, we are currently flying up, I think only 1,000 feet above the Earth's surface, traveling 400 miles an hour, collecting canisters of air, which is kind of surreal.
I think it's investing in the future, I come from an area of the country, Sardis, Alabama, where 8% of the people there have a bachelor's degree. When you see those workforce gaps, it's important to invest in students.
This personally gives me the chance to do a project, start to finish completely, which is something that I haven't really done before in this capacity. So I think that'll be a big plus, just to show that I'm capable of coming up with a research question, carrying out the experiments and the data collection, and then actually coming up with a conclusion.